Welcome to the grade 11 Foundations course. This is the first video that aligns with your very first assignment. A couple of housekeeping items. I'll talk about most of this in class, but the basic flow for these is usually you're going to watch the video. You see, I'll go through some examples, and you're the same as what you would normally have in a lecture in class, and then you'll attempt the assignment. When you finish the assignment, you hand it in to me, I will mark it, and you move on to the next video that goes with the next assignment. Okay? And there's more there, and again, I'll go over that in class in more detail. So here's the first bit in your new grade 11 course. It's going to build off of what you learned in grade 10 with angles. What you learned with angles in grade 10 was mostly to do with straight lines, and the fact that a straight line has 180 degrees, and triangles, and a few things within triangles, but mainly what you would probably remember is if you add the three angles together inside of a triangle, the total will be 180 degrees. And the other big one that most people already know is when you see this symbol, that means it's a right angle or 90 degrees. So this year we're going to be looking at another angle property, which is called parallel lines. And specifically, we're going to be looking at parallel lines with a transversal through them. So this line that goes through at least two other lines, it can be more, but usually two, is called the transversal line. And so it's the line that intersects two or more other lines at distinct points. So we're going to be looking at the relationship between parallel lines that have a transversal through them. We'll look at a few properties. They're fairly straightforward, and then we'll look at some examples. Okay, so the first one is we're going to look at interior angles. Now, interior, building on the language you already know, interior means inside. So what we're going to be looking at are the angles that are on the inside of your parallel lines. And so here are my two parallel lines with a transversal through them. And here's an interior angle, another one here, another one down here, and another one down here. So let's align my board here real quick. More accurate work. So right there. Interior angle, another one here, another one here, and another one here. Now there's a couple of things about interior angles that we can talk about as far as relationships in between two parallel lines. One relationship is the relationship between co-interior angles. Okay, so co-interior, co-together, interior, inside, so angles that are together on the inside of parallel lines, and alternate interior. Okay, so alternate means on across from or on the other side from. So we're going to be looking at two angles that are on alternate sides of the transversal, but on the inside of the parallel lines. One other note before we go on, a way that in a diagram can show you that two lines are parallel are these arrow symbols. These arrow symbols let you know that you can assume that the two lines are parallel. If you don't see these arrow symbols, they might look parallel, but you can't assume that they're parallel. Okay? So the arrows in the middle of the line tell you that two lines are parallel. So let's look at the first one. I give it the shortcut name of the C rule, and you will see why here in a second. And when I was going to school, that's what we called it. Your textbook was calling it co-interior angles. And so, to do a quick little highlight of what we're looking at here, the C rule, and the reason it's called the C rule is because it applies like this. You can see it makes the C letter, and we're going to be looking at, as it said before, co-interior, so angles on the same side. And so if I look at this angle here, A, and this angle here, B, so A and B, if I were to add those two together, the total would be 180 degrees. So angles together on the inside of your parallel lines will add 180. Now this also works for a backwards C. So if I was to look at those two angles, and I added them up, let's call this one X and Y. X and Y would also add up to 180 degrees, so this is a backwards C. Alternate interior angles. And this might be a good spot to mention here in the video that if you're following along with this course with the iTunes University course structure, this video is obviously there, your assignment will be there, and I'll have a PDF of these slides so you can download those as well, and you can fill the notes in as you go. Obviously, if you want to slow it down and pause the video at any time, you can. If there's something you don't understand as I'm explaining anywhere through the course, you can just pause the video, raise your hand, and ask me to come over to clarify. All right, continuing. Alternate interior. And so this one is the Z rule. See here why they call it the Z rule. There, we make a Z. So this time I'm looking at the alternate interior. So if I look at this one, the one that's on the alternate or the other side of this transversal is over here, and it's on the inside. So there's A and B. These two angles will be equal. And then the same as I could do a backwards C up here, I can do a backwards Z as well. And so if I look at this backwards Z, and we look again, we'll say, all right, if I'm looking at X this time, the alternate side will be over here. X and Y will add up to, or sorry, will be equal. So there's alternate interior. So there's your first two rules, fairly straightforward. Let's look at our next one. We're going to look at exterior angles this time. So as the name implies, exterior of side. So these are all of your exterior angles. And this time, the rule that applies is that your alternate exterior angles are equal. So fairly easy to remember because alternate interior equal, alternate exterior are equal. So if we look at this one here, A, right here in that corner, the alternate side of the transversal, so the other side over here, this is your exterior, so A and B will be the same. If you look up here, let's say we look at X, alternate other side of the transversal, exterior, Y, so there is your other one, X and Y are equal. Pretty straightforward rule. Now, corresponding angles. Corresponding in English means that it goes along with, right? So if I was to look at just the top half, so just this line and this part of the transversal, and it looks like this, we could kind of split this up into four quadrants, right? So top left, top right, bottom left, bottom right. And then I could do the same with the bottom line. I could split that transversal in parallel line into top right, top left, bottom right. So what this rule tells you is that if I have an angle here, the top left, then this angle down here, top left, the bottom parallel line transversal, they will both be the same. Top left is equal to top left. And then again, if I look here, top right, these two will be the same. And so if they're in the corresponding position with one another, they're equal. Another straightforward rule. All of these are fairly straightforward. The only difficulty in their problems is recognizing which one to use in which situation. That will come with practice. Okay, so let's try a couple of examples here. And I'll show you with some numbers, and I'll show you how you can basically get any, you can fill out an entire one of these with only having one of the angles. And so let's fill in a number here. Let's say this looks like it's around 130 degrees right here. and we're going to fill in all of the rest after that. So A, B, C, D, E, F, G. Let's fill those all in. Okay, and now we'll say angle A equals angle symbol, angle A equals. And then we'll just fill out the rest of this. Now, you'll notice when you're going through that maybe there's more than one rule I can use for solving these. And we're going to be relying on some of the knowledge you had from grade 10 with angles, but I'll explain them as I go through. So the first one, if I look at this 130 and say perhaps D, the angle D, I notice that's top left and this is top left, the same as what we just looked at in our last rule, corresponding angles. So I know that D is exactly the same, right? So I write in that angle D is 130 degrees. And if I was asked for the reason, I would put corresponding angle. So let's fill that into the diagram. I always recommend you fill in your numbers in the diagram. Next, we'll go to, let's say, angle A. You don't have to solve these in alphabetical order, it's just the way they're listed. So we're going to go to A next, and you say, well, which one of the rules out of the ones I've already learned does that fall under? It doesn't seem like it's any of them. Well, it isn't any of them. Right? It goes back to last year, and you're relying on the knowledge, right, that you've got a straight line right here. So in that straight line, you know how many degrees there are in a straight line. There's 180 degrees in a straight line. So if there's 180, there's 130 right here. A has to be 50 degrees. Now last year we called that the supplementary angle theorem, abbreviated as SAT, which basically means that there's 180 degrees in a straight line. So let's fill that in. Now we're going to come across with angle E, the first angle where there's several different reasons or theorems I could use to figure that out. I could once again look at the fact that I have a straight line down here and say there has to be 180 degrees in it. So D and E put together have to be a total of 180, so E has to be 50 degrees. The other way I could look at that is I'd say top right, both of those are the same, because they're the same corresponding position, so corresponding angles tells me that E is 50 degrees as well. Now, angle C, let's go to that. If I look at C and combine it with E, looking in that spot right there, I've got my C rule, which tells me co-interior angles have a total of 180 degrees. So C must be 130 degrees. If we were asked for the reason, we would say co-interior. Now going back to last year, you would have also had a theorem called the vertically opposite angle theorem that tells you that if you have an angle here, let's call it 80 degrees right here, then the angle straight across from it is going to be exactly the same. So 130C is straight across from that, okay, from an intersection of two lines. So C would be 130 by the vertically opposite angle theorem as well. Right? So again, more than one theorem. B, all kinds of theorems we could use for B. Right? I could use the vertically opposite theorem that tells me that these two angles have to be the same. I could use the backwards C rule here. Right? It tells me co-interior angles have to be the same, or co-interior angles have to add 180, so B and 130 have to add up to 180. So any of those would tell you that B is 50 degrees, and you would just list the reason that you used. Now we start to fill these in quickly, I would do F and G using the corresponding angle rule. Right? So bottom left, so F has to be 50 degrees. Bottom right, so G has to be 130 degrees. One more quick example here. This is a diagram that comes up very often. A very typical example you would see. Now, right here I've got these arrows here and here that tell you that the top line and the bottom line are parallel. On the right and left lines I have double arrows. They can't have single arrows telling you that these two are parallel, because if they had single arrows, they would be telling you that this line and this line are parallel, and that's obviously not true. So since these two are parallel, you give them a double set, right, to distinguish them between the top and bottom. All right. Now let's fill in an angle and see if we can figure out the rest. So let's call this one 110 degrees, and then we'll solve for x, y, and z. Here's where you have to do a little bit of creative thinking. The first thing I would do, I've got parallel lines, but it's hard to see the transversals that you need to work with. Right? And in fact, what I've got is two sets of parallel lines, and what you have to do is stop and imagine the one set of parallel lines being transversals and then switch. You'll see what I mean. So I'm going to extend these lines. Anytime I see lines that aren't really extended, I extend them on my own. And then it looks more like the diagram we were working with above. All right. So then you have to stop and think, all right, if I just close this off like this and look at just the left-hand side, then this looks exactly like my diagram up here. Right? And I'm just looking for x. Right? And in this case, this line and this line are your two parallels, and this becomes your transversal. And what I have here is the C rule, co-interior. So you already know that the co-interior angles add up to 180 degrees, so x must be 70 degrees. That one was fairly easy. Now, the hard part. This is where it's great. You have loose leaf, you can work with this. What I'm going to do is I'm just going to group these all together. And so I can work as this, oops, drop some here to include that as well. So let's bring this down. Didn't quite get that exact. Here, so let's just erase it off for a second. Just continue that. I'll try this again. All right. So here's our diagram on your paper. Now, let's say I want to figure out y next. You might say, all right, let's look at this right-hand one. You've got no information over here at all. I've got two parallel lines, but no information. So you can't make information up, so you can't solve it like that. So now what we're going to do is just rotate it around this. And now we're going to look at it and say, all right, now I've got these two are parallel. Right? Both have a double set, like this. And these are now in the C rule. So this is where rotating your paper can help. And so if I look at my C rule now, my C rule is right here. So this angle and y have to add up to 180 degrees. So that must mean that this is 110 degrees, or for these two to add up to 180. So let's rotate this back around now. y was 110 right here. Carry with me, but there it is. Right. And now I can say, all right, let's rotate it back so it's in the original orientation. I've got this set up, my backwards C rule, so these two co-interior angles have to add up to 180, so Z has to be 70 as well. Very typical question there. And if you printed off your notes, here's a little summary. If you didn't print the notes, you can copy this down. If you did, there's a little summary, a little nice one-page summary of the rules. So you can keep that kind of, if I was doing my first assignment here, I would keep this right next to me as I was going through. Or even if you've got lots of space, I would just take the original 3 pages here with all the rules and kind of spread them out and have them right there instead of my assignment to work with. Okay, so give that first assignment a try. If you're having any difficulties, raise your hand. I'll come by and help. If you finish, hand it in, and we'll start on the next video.